Well, in this video, I would like to discuss the concept of acceleration. It's a very crucial concept in distance time graphs and speed time graphs, basically, mainly associated with speed time graphs. Let's begin to discuss what acceleration really is. So acceleration is the increase in speed over a period of time. Basically, when a car increases its speed from zero or, well, any variations in speed that happens, the increase in speed is the acceleration, and the rate of decrease of speed is the deceleration of any object for that matter, not just a car. So to calculate acceleration, the formula is speed divided by time. That is, if we're not using a speed time graph to calculate this, but the unit for acceleration is the same everywhere, which is meters per second squared, if the speed is in meters per second and time is in seconds. And if the distance is in kilometers, if the speed is in kilometers per hour and time is in hours, obviously, then it's kilometers per hour squared, basically. So let's move forward to how to calculate acceleration from a speed time graph, which is something we briefly discussed in our previous video where I covered speed time graphs. But let's do a bit of a recap just to perfect it for you. So in this diagram, we have a speed time graph of a car journey where it's, well, increasing its speed, reaching a constant speed, and then slowing down. Okay, so using this graph, we need to calculate the acceleration during the first 20 seconds and the deceleration during the last 10 seconds of the journey. Now, in order to do that, in a speed time graph, the gradient of a particular interval is the acceleration. So let's find out the gradient. The acceleration is happening in the first 20 seconds. So let's find it out. Acceleration for the first 20 seconds is going to be the gradient. And for that, I will have to mark two coordinates because we will use the coordinate geometry formula of finding out the gradient. So this is the first point, this is the second point, this is 0, 0, and this is 20, 20. And using that, I would find out the gradient, which will be y2 minus y1 over x2 minus x1. And 20 over 20 is just 1. Therefore, the acceleration was 1 meters per second square in the first case. Let's find out the deceleration in the last instance, in the last 10 seconds. So for that, again, we will have to mark two coordinates. This would be 50, 20. And this one will be 60, 0. So the deceleration, let me write it down in short form, for the last 10 seconds would be y2 minus y1. It's going to be, let's do 0 minus 20 all over x2 minus x1, which is 50. Okay, so that means minus 20 over positive 10. And because we're calculating deceleration, which is already accounting for the slowing down of the speed, now the gradient is going to be a negative value, but the final answer, we will ignore the negative value, and I will highlight again why. The result is minus 2 of finding out this gradient, but the deceleration, when I call it deceleration, it's already accounting for this negative. When I say deceleration, it's already accounting for this negative. So the final answer would just be 2 meters per second squared. We're ignoring the negative sign because the deceleration is already covering the negative. So there we go. We have covered this. And with this, we come to the end of this video. I hope that you understood these concepts and you enjoyed this one. Thank you for watching this. I hope to see you in the next video. Until then, stay tuned.